So in the last day, we got you reminding yourself of the sketches that we did in MCV4U in the Advanced Functions class first semester. And we did that because if you recall back to last semester, there were all sorts of opportunities when we were drawing those sketches that we had to do a little bit of guessing or some gimmicks to get past it because we didn't have calculus or some of the ideas of this course. So what we're going to do is revisit all those things and see how we can tighten up the mathematics and maybe make our graphs a little bit more accurate. So one of them is re-looking at how we found asymptotes. So this shouldn't be new. The definition of an asymptote is a limiting line. The graph of the function gets close to this line but never touches. So we would have described an asymptote like this before, but this new language of saying it's a limiting line can actually mean something a little bit more detailed now that we know something about limits. You'll recall in the first unit we did an assignment just on limits where we talked about how you can get really, really close to something. When we're looking at the secant, we get the secant really, really close to zero, that it's essentially zero. Well, that similar idea can be applied to asymptotes. So it allows us to tighten up our mathematics when we're describing how an asymptote looks and how it behaves when we're graphing rational functions. So last semester, when we looked at a situation where we were graphing a function that had a vertical asymptote at 2, we did a little bit of a gimmick. We did some test points. We did a point just to the left and just to the right of 2. So we would have substituted in 1.9 because it's just to the left of 2, or 2.1 because it's just to the right of 2. Well, that's great and it works, but we'd like to formalize that a little bit better, and we can because we know something about limits. So instead of saying I want you to do a test point just to the left and pick 1.9, I'm going to formalize that and talk about what happens on the left side and the limit as it approaches the function to the left. We know about that notation now. We can actually write the limit as x approaches 2 from the left, and that's what this negative symbol means, from the left, and go and look at the function and say, what does the function do as it approaches the asymptote from the left? And naturally then we can also look at the other side and describe what the limit of the function is when it approaches the asymptote from the right. And of course that one would have the plus 2. So the good news is the math we do is going to be exactly the same. We actually, in our head, will pick a number that's just to the left of 2, like 1.9, and a number that's just to the right of 2, like 2.1, and plug it into the function to see if it will produce a positive or negative. The only difference is in our notation. Because we have limiting notation right now, this notation of limits, that we didn't have last semester. So the concepts that we studied today are going to be very similar. So in this example, we're going to look at a couple of rational functions. We're not going to go through the whole process of graphing it. We're going to do that in a couple of days. What we're doing today is only practice using the new notation to describe the asymptotes. So this question is actually going to say, find the vertical asymptotes and describe their behavior. So very quickly, if we look at the first one, remember that vertical asymptotes occur when the denominator is equal to 0 because we can't divide by 0. That produces the asymptote. So in this case, we know it's pretty obvious the vertical asymptote happens when x equals 0. Last semester, we would have picked a number to the left and right of that and actually just done a test point. What we have now is this new notation. So if I want to consider what happens to the left, I write the limit as x approaches 0, this asymptote, from the left of f at x. But in your head, you're going to do the same thing you did before. Let's pick a number like negative 0.1. That's just to the left of 0. Put that into the function and describe what it does. Well, when you put in that number, the 1 isn't changed. It's still positive on the top. But negative 0.1, when you plug it into this function, it's going to produce a negative on the bottom. And I don't care really what the number is. I know it's going to be really, really tiny. But when you take a positive number divided by a negative number, a negative small number, it's going to get you a negative infinity. And so the graph is going to go down forever as it gets close to the asymptote. Again, the concept is exactly the same as what we did last semester, but the notation is different. So if I want to consider something just to the right, I would say the limit as x approaches 0 from the right of f at x. And again, in our head, we put in a positive number just to the right of 0. Is not going to change the 1. The 1 doesn't care what the x is, so it's going to be positive. But I put in 0.1. That's a positive number, and a positive divided by a positive is positive. And so the graph is going to go off to the positive infinity. And so there's the notation. I'm not going to go through the whole process of graphing all of this. I'm just going to graph very quickly the asymptote at y equals 0, or x equals 0. And know from the left, it tells me it goes down like this, and from the right, it goes off like that. And we remember that this is one of the steps we do when we're going off and graphing these functions. So it's very straightforward when we have a simple scenario like y equals, or f at x equals 1 over x. But if we have a more complicated one, we'd still do the same process we'd done before. So if I look at the B question, it's the function is x plus 3 over x squared minus x minus 6. If you recall, a great strategy was to put this in factored form before you started talking about the vertical asymptotes. To find the values for x that get you a 0 on the bottom, it's much easier to look in this notation than it is in this notation. So I've done step 1 for you and factored it. And now it's pretty obvious. You can see that the vertical asymptotes are going to happen at 3 and negative 2. Again, last unit, we would have now picked numbers, test points on either side of those. Here, same idea, but we're going to use the different notation. I'm going to start by looking at this one. I'm a little bit of a stickler for this. I like to look left to right. There's nothing, no rule that says you have to do that one first. You can look at the 3. But I'm going to do this one, and I'm going to look at what happens to the left. So the limit as x approaches negative 2 from the left of f at x, and the limit as x approaches negative 2 from the right. That's my new notation that I'm discovering today, but my idea is still the same. I pick a number that's just to the left of negative 2. So in my head, I'm not going to write this down, but in my head, I'm going to be plugging in negative 2.1 and negative 1.9. This is just in my head. So if I plug in negative 2.1 into here, you'll see that plus 3 is going to be positive. If I plug it in here and I minus 3, that's going to be negative. And if I plug it in here, negative 2.1 plus 2, the plus 2 is not big enough to change it to a negative. So on the bottom I have a negative times a negative, which will be a positive. Positive divided by a positive is positive. So it's going to go off to positive infinity. Now I'm going to plug in negative 1.9. I plug it in here. Of course, the plus 3 is bigger, so that'll change that to a positive. I plug it in here, and I get negative 1.9 minus 3 is going to make it more negative. And then when I plug it in here, if I go plus 2, that's going to actually switch it to a positive. And that means the negative times the positive on the bottom will be negative. Positive divided by negative is going to be negative, and I get that. Since I have two vertical asymptotes here, I have to investigate the left and right side of the other one. So very quickly, I'll say the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right, f at x, f at x. And again, in my head, just to the left of 3.9, 3 is 2.9. That's going to be a positive on the top, minus is a plus. It's going to be negative infinity. And if I pick a number just to the right of 3, like 3.1, plus 3 will go positive, minus 3 will stay positive, and this will be positive, and this goes to positive infinity. And there I've done and investigated the behavior of all the asymptotes. If I were to graph this, it would look something like this. I would have a vertical asymptote at -2 and another one at 3. From the left, it goes up to positive infinity. From the right, it goes down. And when I look at 3, from the left, it goes down, and from the right, it goes up. And then I would go off and find all the other information. But for today, all we're going to do is investigate the asymptotes.